welcome, Piotr. And
Hello.
good luck. The stage is yours.
Thanks. So, hello everyone. I would like today to talk to you about Minitest, which is, for various reasons, one of my favorite Ruby libraries, especially when it comes to the standard library suite. And I want to maybe show some of the things that you might not know about Minitest and some of the things that I like about it. How many of you know what a daily coding problem is? Okay, so a daily coding problem is an email. One of the ways of dispersing daily coding problem is email that shows up in your mailbox daily, and it gives you an example recruitment task that people were asked to solve, or, where there is a rumor that those were asked, and there are various levels: easy, medium, hard. You don't know which one you'll get, and I think the kind of economic model is that you can pay to see the solution, but you can get the task for free. And I get them. I sometimes catch up on them just for fun. Also, they are excellent if you want to learn for example, a new programming language, because then you have a task that, in theory, should be solvable in about half an hour tops. And then you can maybe play with a language that you don't know if the task is easy, or have an interesting start to your day if the task is more complicated. And one of those was number 1100, which was, good morning, here's your coding interview problem for today. This problem was asked by Netflix. Given a sorted list of integers of length n, determine if an element x is in the list without performing any multiplication, division, or bit shift operations. Do this in logarithmic time. So that's obviously the gist is in the last bit, but let's see how you could approach this from a standard Ruby perspective. You have a freshly installed Ruby 3.4.1 for various reasons. 0.1 was released. There was actually one reason. It was a wonderful fuck up of like .0 was released with the def suffix, so .1 got released like several hours later. But let's try to TDD it. And we'll use Minitest, which might not be necessarily the kind of Minitest that people used to write 10 years ago, or maybe 15 years ago, or maybe in your code bases that you happen to encounter that still use Minitest, or use Minitest again for various reasons. It's still the default in Rails. So one of the ways you can most conveniently run this kind of things, or I tend to run them, is to just have one file where you have both the testing and the implementation. So you can require Minitest autorun. This will give you a file that, when you run it with Ruby, Minitest will hook up and actually run all of the tests. You can require Minitest Pride to give you some nice colors. And then we can actually do this in Minitest nowadays, which is use describe and it blocks. And we can say that we want to have a method found, question mark, because it's a predicate, that takes a list and takes a number. And let's start with saying, like, if we have a list of those numbers, the definition says that they are sorted, so they are in increasing or ascending order. Then, the simplest reasonable test that we might want to keep is to check for all of those numbers that they are actually in this list. And again, one of the first things that I want to show here about Minitest is that there is a library or a submodule called Minitest spec that is now required by default, by Minitest autorun at least, that you can use this kind of syntax, which I personally find more appealing without going all the way to RSpec. I actually very much like RSpec as well, but I also like Minitest, and I like this kind of middle ground, the kind of hipster middle ground, being the person hated by both sides is usually when I find myself for various reasons. But again, we can use a plain minitest assert. We can also do that in Rails and just, run this. What would be the easiest implementation that passes this? An ADF, the simplest one that doesn't throw a syntax or a runtime error, there's no found method, or it has the wrong kind of. Like, obviously, this is the easiest one. We are making the typical TDD, extremely rigorous. Don't do this in production code, but we're playing with solving a task. So in a rigorous TDD, we can do this, and we run it. It would have been in colors in your terminal, but not in this particular text-based presentation software. So we run this, and we have like one assertion. It passes. Obviously, the implementation is wrong, but it passes all the tests. Almost 800 assertions by second. OK, so the obvious thing we are missing is something like this. So let's have a list that has all the other numbers and make sure that none of those numbers are actually found in that particular list. So this should be our fundamental test. Again, a lot of people say you should have one assertion per test. There are fair reasons to have one assertion per test, but also, we're playing around. Also, this is a presentation. Also, I needed to fit the code on the slides. Also, this is something you do in the, let's say, first 15 minutes of your day, just to have some fun and get your creative juices flowing. So again, the simplest implementation would be something like this. We are Rubyists. We have the include predicate on lists. Does it use multiplication, bit shifting? Not at all. It just runs this, and again, we run it. It passes. It's actually twice as fast, 1,400 assertions per second, just because we are making twice as many assertions, and the biggest time spent is actually running minitest. So again, a very nice spec-like language that is already right there for you in minitest. You don't have to necessarily use anything else. It's in the standard library. So did we solve the problem? Did we determine if an element is in the list without performing any multiplication, division, or bit shift operations? Yes, we did. Like list, predicate, include number doesn't do any of those things. Technically, to the word of the task, we did it. But are we doing this in the logarithmic time? That's an excellent question. How can we check it? So we probably aren't. Like the only way, if you did at least minimal number of this kind of tasks to do this in logarithmic time is to actually benefit from the fact that this array is sorted. We are not doing any of this, but let's first do some initial rudimentary checks. So let's see whether a very large number is passing that predicate. So like the number million, whether it's in the list, and the number one less, one fewer is not in that list. This is a good test to have in case you want to start implementing various algorithms to pass it, because depending on the complexity of your algorithm, this one will already potentially take a lot of time. The other kind of edge case is to have a very long list, like a list with 1 million elements, and to check whether the next to last element is actually in this list. So we can see whether the list include predicate is any good in those two, maybe not edge cases, but edge-ish cases. And we run it, and it still runs in 0.03 seconds, and it runs with like 150 assertions per second, so an order of magnitude slower than previously, but still we don't know whether, maybe there's some magic in the include predicate. Maybe it's implemented so quickly that it actually is somehow, very fast. Maybe, just maybe it does. It has an optimized version that kicks in for this kind of arrays, sorted arrays of integers. So how can we check it? And again, surprisingly, featureful minitest. It's like minitest is 2,200 lines of code. that's the whole library. You can actually sit down in an afternoon, read it in full. There are a lot of comments, so it will take some time, but like the slot count or Tokay shows 20 to 100 lines of code. This is a very small library that is extremely featureful. Minitest benchmark is right there. The way to use Minitest benchmark with Minitest spec, which is in none of the documentation. So one of the PRs I actually didn't get to, but will have now that I had to create slides for this talk, is to have examples for Minitest spec, is to have a describe block that has to have a name that ends with benchmark. Took me surprisingly long to figure this out. And the way the Minitest benchmark sublibrary or module works is that you define a bench range. In this case, we want the benchmark to run against numbers 1 to 10,000 with an exponential growth, because we want to have a logarithmic. We want to check against logarithmic fitting, so whether our algorithm is actually have logarithmic complexity. And let's just play with at least to some the new-ish Ruby syntax. Let's have a scenario that has a list of numbers. I went all the way to new things in Ruby, so I will explain why we need this alias method. But the way we want to do this kind of benchmarking is if we need any kind of setup or pre-configuration, we want to run it outside of the actual test. So let's create a setup where for all of those benches, so 1, 10, 100, 1,000, 10,000, let's create a scenario that has an array of 1 to this many, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1 to 100, to 1,000, to 10,000. And then let's look for a number that's exactly in the middle of that. So we can have, if we do iterative search, we will see that our algorithm is not necessarily logarithmic. And the way reduce works, this basically creates a hash of benches or bench values pointing to those scenarios. And then Minitest provides us with a bench performance logarithmic method that takes a block and it runs this block with those particular numbers, takes a node, how long does it take, and then checks whether it actually fits, in this case, a logarithmic curve. So whether it actually is a logarithmic complexity scenario. The way I needed to run this to actually work is to run this 100,000 times, because otherwise this implementation is so fast that this fetching was impacting the performance of the whole block. So I actually ran it 1,000,000 times, but I checked that for 100,000 time it still works. And again, the interesting thing I wanted to play with is how to destructure a data object into something that takes a list and a number, and we have to have a two-hash method. So for scenario to get the structures to keywords arguments, the scenario class needs to have a two-hash method, the implicit conversion. So unfortunately, the data class doesn't provide it. So for various reasons, this is an excellent topic for another talk. What are the differences between two-hash and two-H, two-array and two-A, two-string and two-S, and so on. Anyway, do you think this will pass? Yes, no, maybe. I have no idea what you're talking about. You all have 4 hands, you can raise the right one. Right. This obviously fails because the nice thing it does actually, it also shows how much time it ran those 5 cases. So for 1, 10, 100, 1,000, and 10,000 elements. And while it's pretty fast in general, you can see that in this particular case, it's actually surprisingly faster for slower for the smallest array. But in general, we can see that starting around here, it grows by an order of magnitude. And this is clearly not a logarithmic growth. This is what, 50 times? This is 5 times, this is another 10 times. So what Minitest gives us, it tries to draw a function. It tries to fit, in this case, a logarithmic function that would fit against those benchmark numbers and those times it measured. And then it gives you how much it fits an actual logarithmic curve with something that is called R-squared fit. There is a very nice explanation in the Minitest code itself. And in this case, the default, you can define this number, but by default it tries to fit it by R squared of 0.99, so almost perfect, 1% difference to the fitting, and our curve clearly doesn't fit the logarithmic growth, and indeed the best fitted it manages is like 0.57. You can think about this, about somewhat how much it fits. Clearly it doesn't even fit, like it barely fits half-ish of what we would like to have. So how can we implement this method to actually work, to use this fact that those numbers are sorted? This is not interesting. The interesting bit was that we cannot use multiplication, division, or bit shifting, so we have to do something like this, which is, let me actually press the right button. So this is effectively just addition, but because Ruby is a very terse language, what happens here is we grow this number twice every time just by adding, and we use the very nice number spaceship operator. This is the method that gives you whether the numbers are equal, one is smaller, one is greater. The way the spaceship operator, or the method, it's actually the spaceship method on every integer, in this case, is that it returns -1 if the number is smaller, 0 if they're equal, and 1 if it's large. So we select some kind of index into that array. We compare our number against that pivot, if you're into this kind of algorithms, and then if it's smaller, then we check, we run this against the beginning of the list. If it's larger, then we have to check the rest of the list. If it's 0, then it's true, and we can do some rudimentary checks whether if the list is empty, the number is not there. If the number is smaller than the first element, it's not there. If it's larger than the last element, it's not there. And it's there if it's equal to the first and last elements. And again, this is not an optimal way of implementing this method, but it does tick off the requirement that it doesn't use multiplication, division, bit shifting. It just uses addition in a way that is like multiplication, but the best we could do. And if you remember, when we were using the default include predicate, the best we could do is a growth that it already took 2.5 seconds for 10,000 elements. But the nice thing about this approach, which is not in C, it's pure Ruby. I didn't even run it with YJIT enabled, but we can go all the way to 1 million here, and we can still have reasonable times, and it actually passes, because the small cases are actually slower, but if something is slower by 200 milliseconds, is it really that much slower in practice? But then we can see that it actually grows in a logarithmic fashion, and indeed, Minitest tells us, okay, I was able to fit this into a logarithmic curve with R squared of 0.99 or greater. So this is, to me, an excellent example of a thing that Minitest provides, because it provides you with something that is actually useful now and then. Now and then you actually might want to have this kind of performance-based. Maybe there's a hot path in your code and you really want to make sure that this algorithm is never made worse. Or you are building some fundamental library and want it to be particularly fast and do not degrade with the size of the input, and so on and so forth. You might want to have this kind of testing, but also, when you're debugging, there might be cases where, this API gets really slow when the input grows, and it gets slower and slower, much faster than the growth of the input. So why does this happen? And having this kind of tests is, they are not something hopefully you run into like a monthly basis, but now and then it might be super useful. And again, this is something that is right there in the Ruby standard library and just works. I want to get one thing out of the way. One of my favorite commits to Minitests for extremely selfish reasons was this one from, let's see, 13.5 years ago. Adding is complicated. But in general, it's from 2011, added some choice quotes to the README. And there were 2 quotes added. One is from Wayne E. Seguin. You might remember him. I think he was the original author of RVM. And he said, I had a class with Jim Wyrick on testing last week, and we were allowed to choose our testing frameworks. Kirk Hines and I were paired up, and we cracked open the code for a few test frameworks. I must say that Minitest is very readable, understandable, compared to other 2 options we looked at. Nicely done, and thank you for helping us keep our mental sanity. So again, this whole Minitest package that runs by default on Rails, that has a ton of very interesting, useful features, is 20 to 100 lines of code. The other quote is from some random guy. Again, I can praise enough the idea of a testing specking framework that I can actually read in full in one sitting. This is something that I'm still maintain is true. So the main bits of Minitest that to me are kind of a very nice run-through of what Minitest provides is Minitest Test, obviously, is a small and incredibly fast unit testing framework. It provides a rich set of assertions to make your test clean and readable. Minitest Spec is a functionally complete spec engine. It hooks onto Minitest Test and seamlessly bridges test assertions over to test spec expectations. And then Minitest Benchmark is an awesome way to assert the performance of your algorithms in a repeatable manner. Now you can assert that your noob coworker doesn't replace your linear algorithm with an exponential one. Again, the README is not on the kind of shy side, but I really like those bits. Minitest Mock by Stephen Baker is a beautiful tiny mock and stub object framework. Mocking and stubbing in itself is a separate talk. I have some issues with mocking and stubbing in general. I have, as usual, issues with both over-mocking and people who say over-mocking is fundamentally wrong. Like, you can over-mock, but you can actually use something that is called verified doubles and make sure your mocks represent reality. But this is for another talk, hopefully. If Visuality will have me again, then maybe I'll talk about it next time. Minitest Pride shows pride in testing and adds coloring to your output. I guess it is an example of how to write I/O pipes too. And this is, again, a bit tongue-in-cheek, but in general, one of the very nice things about Minitest, it has a very nice way to extend it. If you have some kind of, I wish there was an easy way to pinpoint the slowest test or something like this. Like those things, are already built in a lot of external gems, external to Minitest, but also, the example of how to write I/O pipes for Minitest is also right there. And Minitest Test is meant to have a clean implementation for language implementers that need a minimal set of methods to bootstrap a working test suite. For example, there is no magic involved for test case discovery. So again, the way it works is if you've ever written kind of traditional Minitest, where you have a class that inherits from test unit, or Minitest Test, I think, by now, or Minitest unit, I think, maybe, then I haven't written, like, from scratch, like clean, pure Minitest tests in a while. I always use the Minitest spec syntax, but there's that, and those are just methods that start with the test underscore name, and minitest just checks who inherits from minitest classes and runs the methods that start with test underscore. So it's a very simple, no magic involved test case discovery. And the way minitest spec works, it actually turns those describe and it blocks into a set of classes and methods that are defined from the strings that you pass to the describe and it methods themselves. So, two more examples of the tests that people find surprisingly often hard to write. So, for example, I/O testing. If you're writing a new CLI tool, one of the things is, do you really want to test what it outputs? And, do you really want to test drive this? And the nice thing about minitest, it actually makes it really simple. If you define your class as, for example, some kind of wrapper called CLI that takes the arguments that were passed on the command line and then runs, then you can say that if your tool it's, for example, called CLI, if you pass --help, this percentage W turns this into an array of strings, then this must output help info, just as an example. And the thing I want to showcase here is that minitest spec, on one hand, uses this old-style rspec-like this. In rspec, those were should and should not, I think. So it was like object, should, equal, and so on. That was in rspec deprecated because it required worldwide or like whole Ruby interpreter run stubbing or actually extending the object class. rspec, if you remember, migrated to the new syntax for, like it was new 10 years ago probably, where you could say expect, then pass something, to equal or to not equal. So minitest also this kind of migration, but it actually went with the expect. Rather than expect, you use the underscore method. So you still have like visually something must output or must equal something else or won't equal. And one is that minitest believes that should and should not are definitely too weak words for a test suite that requires that something either must work or won't work, but also has this nice symmetry of must and work having both 4 letters. So you can actually stack your examples one under another, and they're very nicely are aligned if you're one of the people who used monospace fonts, because nowadays people use non-monospace fonts where the code. Like famously, the author of Go doesn't use syntax coloring and uses a variable with fonts, and still does quite awesome programming. So for this, we can have a CLI class that takes an argument array. It can default to RGV, which is whatever your script got passed. You have a run method, and you are golden. Like there is a way to just test outputs in minitest. It basically hooks into standard input and output. Of course, you can do this by hand. Another thing that I like showcasing is how I test logging. Again, logging can be done in various ways. My favorite one is to just have a logger that takes a string IO, and then you run something with that logger, you rewind that string IO, and check whether it includes whatever you wanted to log. And again, you can default the logger to raise logger, but you can pass your own logger that is based on string IO, which is this in-memory string object that the logger can write to and read from, just like an IO object. So this can simulate a file or anything else because, like log4r, for example, or network-based logging also very often has this IO interface. So again, this is something that you can do very easily. And again, I wanted to showcase the syntax where you wrap something in underscore and then just have, this gives you a string. That string must include whatever log you're looking for, and it just works. This is the standard logger from the standard library. String.io is, I think, in core, actually. I didn't even have to require anything to get this running. Logger, obviously, but not String.io. So, algorithmic performance, we've already covered. So, Minitest benchmark provides a suite of assertions: linear, constant, exponential, logarithmic power. So you can say like, this algorithm should have linear performance or constant performance, O of n. Or, unfortunately exponential or power, but, hopefully logarithmic. And the way it works, it benches the test runs against R² fit. Super interestingly, I think when I was playing with that particular task, I found a bug in Minitest because it does this kind of fitting except for linear. And there's a longish comment which I will have to question because it explains why it does basic fitting rather than R². And I have an example minimal test that shows how there's clearly a non-linear algorithm that actually passes the linear test. So, still, after so many years, you have to know the tools that you're using, but again, this is right there. So, the last thing I want to talk about is difftastic. Who knows what difftastic is? Okay, excellent. So, when you work on code and you want to commit it to Git in particular, but in general, if you want to see a diff, the best, according to Unix philosophy, the best we were able to do in the last, 50 years is to have line-by-line diffing. So, those lines changed, those lines didn't. Or those lines changed because we added a comma, but it's a very long line, and the comma is not very visible. There are tools that make it better. You can hook Git Delta, I think, is one of the more popular ones, and obviously there, like GitHub tries its best to show you what actually changed in the line. Difftastic has a different approach. It's a tool for diffing that for known types of files, it actually parses them, builds the usually abstract syntax tree, and compares those. So this is, for example, a Rust diff from difftastic, where it can tell you that those bits actually changed, including like this parenthesis was added, those particular bits. So it's extremely useful for working with any type of code diffing. Another example is apologies that those are not like properly on white background and so on and so forth. I added them an hour ago because the things I want to talk about were released yesterday. So this is, if you look closely, the difference here is not only that the line number 7 is gone because it has import mockable that got deleted, but this line, import isignores function errors from internal.js, got actually replaced into 4 lines because another one was added and then some kind of linter basically put its finger on the scales. But difftastics can show you that, okay, this line is gone, this 4 lines, there's even 5 lines if I'm able to count properly, are in, but the difference is actually that this mockable bit got added, like comma, mockable, comma got added. So the gist of this difftastic is if it knows what kind of files you're working with, then it can show you diffs that are actually about the structure that changed, rather than just, this one line went away, those 5 lines got in, and, at best, it would either show that import stayed around, or it would show that, that from part stayed around. But in general, typical div tools show you at best that something inside changed, or just this whole line is gone and those 5 lines on it. The divtastics basically gives you structural divs. And divtastics has support for all of those languages, among others, and more. Ruby is here, HTML, JSON, YAML, all of the things that at least I work with on a daily basis, TypeScript, and so on. So it's extremely nicely oriented towards helping us work with our stuff. So there is a person, Joel Dropper, who writes a lot of super interesting libraries nowadays. He's also extremely bent on performance, and one of the things I need to dive into is his tooling for testing that runs tests in parallel in a way that's extremely efficient. So he was missing he discovered this divtastic, but he was missing the Ruby binding. So he actually released divtastic Ruby 2 days ago, I think, along with Steven Markgrime, who you might know as SQLite Jesus. He's very much into spreading the SQLite gospel. And what Marko Roth did yesterday was he took that and created Minitest divtastic gem, which gives you exactly this. So you can say that, I have this hash was expected, this is the actual hash. They differ because this is quoted, and this string actually differs by a line. So thanks to divtastic's ability to analyze this as a Ruby object and output it in a way that you can hook into, and then work by Joel, Steven, and Marko, we can just use this in Minitest as of today. So thanks so much. Do check out the Minitest README. I highly recommend reading those 3 files when you have a lot of time, or contrary, have something you really don't feel like working on and need a good distraction. Go and read that. Check out divtastic, divtastic Ruby, and Minitest divtastic, and follow Joel Dropper, Steven Markgrime, and Marko Roth. They are really nicely, they do a lot of very contemporary Ruby work that is super interesting. They're building a set of new web tooling that might be useful, even if you're bent on using Rails. And it's just a pleasure to watch them work and see their talks. I also highly recommend watching their talks. So thanks so much. The slides will be up later tonight at talks.chastel.net. You can follow me on Blue Sky, and I'm happy to also answer any questions you have for now or after the lightning talks. Thanks.
Anyone?
Excellent.
Thank you for your presentation. I have a question. In your opinion, can you maybe define a criteria for new project to pick RSpec over Minitest?
Okay, the question is, can I define criteria for picking Minitest versus RSpec for a new project? The fundamental one is familiarity of people who work on that project. I think it's absolutely crucial that people who work on a project feel comfortable with the test tooling that they're about to use, because to me, testing is the important bit of coding. Like, there's this famous question: if tomorrow you had to give up your production code or your tests, which one would you give up? And a lot of people say, obviously, test. The production code is too precious. But if you consider your tests so clearly less important than production code, then maybe it's good to work on your tests, because, if you give up your tests, then you should technically sit down and rewrite your test suite, and writing tests for existing code very often pushes you towards writing tests that test implementation. This is also especially in the LLM era. The one thing I fear about LLM-generated tests is that they can be very bent on testing implementation rather than behavior. So rather than, this is how the method should behave, and I can refactor it very easily because this is the only inputs and outputs are tested. A lot of tests do heavy mocking, and basically there is one or two ways to make those tests pass rather than a plethora of ways depending on how you implement things. So to actually come back to the question, minute test versus RSpec, both are perfectly fine, both have a ton of tooling. We default to minute test at Shopify, and this is the Rails default, but we still have some projects that historically used RSpec or got brought in from outside, or we started maintaining them, and we keep them on RSpec, obviously. There's no point in rewriting your test suite. If your team prefers RSpec, that's perfectly fine. If they prefer minute test, perfectly fine. Just make a decision, go with it. It's like, double quotes, single quotes, whatever, Rubocop configurations. Joel Draper actually has his own Rubocop configuration, and that he uses by default, so he just doesn't have to think how to configure every single project. And one of the things that is extremely telling about him in many ways is that he actually uses tabs in his Ruby code. But he has this as a separate rule. So you can import everything except the thing that turns spaces into tabs for indentation. And again, we can have a very long discussion whether it should be tabs or spaces. I can discuss both sides for like 3-4 hours easily. And this is probably the same minute test versus RSpec. Sure, you can discuss, but RSpec historically was much slower. Now it's just as fast, has a ton of tooling, minute test as well. Just use whatever, just write tests. It's just so much more important than which way you write it. You can write your own testing framework, that's also perfectly fine. Just hook Difftastic to it because it's so much more useful.
Do you remember the phenomenon of RSpec comparing to Minitest? Because Minitest was always default, and the RSpec is even hated by the creator of Stephen Baker, who was here last month, and he contributed to Minitest. And I don't remember why it was that famous, and still most of us using RSpec comparing to Minitest. Do you remember the phenomenon? Why?
First, minute test was a version of test unit from Java. And initially, actually, minute test was a rewrite of the test unit library that used to ship with Ruby like 1.8, 1.9. So minute test used to be the underdog, which was initially not accepted because the standard library shipped test unit. And minute test was basically, I can show you how to rewrite this in a way that is much more readable and still maintain the same APIs. Whereas RSpec was this whole new behavior-driven development approach that was when the Ruby community was absolutely fascinated with all of the DSLs that we can create. So, like foo should equal bar. That was something that was back then the very fresh era of Ruby for people coming from Java or Python or anything like this. And this is what RSpec brought in with full force, and then had to kind of backpedal with the expect syntax because clearly, monkey patching the basic object class just so your test suite runs. It might look nice, but it has its drawbacks that eventually showed. So this is again why minitest spec uses the underscore rather than just monkey patching object. Historically, it does it for historical reasons, but it won't do it anymore by default going forward, and you can turn it off so it doesn't patch the object class. But again, as you can see, I'm happy to get hated by both sides and use the spec syntax with minitest, and it's also fine. Like, play with code as much as you can and want. That's the fun part of this job. Thanks.
Anyone else? Any other questions? Don't be shy. Okay, so thank you very much.